right, class. Remember, we're in chapter 11 now, and we're talking about rational numbers. And we're going to see that I can take a rational number. Remember, we said a rational number is a fraction, and I can write it in decimal form. Now, what does that fraction bar mean to you and me? That's right, fraction bar means division. So fortunately or unfortunately, it means we're going to be doing some long division here to get the job done. Now, we've seen that decimals can terminate, which means they stop. Okay, they can repeat, which means we're going to have the same decimal and the answer, and they can non-terminate and non-repeat. Now, we're going to see then, let's go through, and if you remember last year in 7th grade, we actually memorized some of these common fractions and their corresponding decimal. 1/4. Now, 1/4. Does anybody remember what goes with 1/4? That's right. 1/4 is 0.25, so I can move him. He terminates. The answer is 0.25. If I look here then, 1/2, well, we learned last year 1/2 is 0.5, so it terminates. 0.50, we stop. 3/4 we know is 0.75. Now, last year though, remember when we got to 1/3, what did we remember about 1/3? Well, if you remember, 1/3 is 0.3 repeating, if you remember. So that means it's 0.33333, which means it is repeating. So I can go ahead and put this 1/3 over here under the non-terminating or repeating. 2/3, if you remember last year, we learned that that is 0.6 repeating, so he can go over there. 3/8. Now, what do you think about 3/8? Well, if we got the long division, we'd find out it terminates. 5/9. What do you think about 5/9? 5/9 is going to be repeating. All right. If we did 55 over 99, man, we would find out that it doesn't terminate or repeat. Same thing happens with, I got to move this down so we can see the last few. Okay, if we look here, 1/6, okay, is going to repeat. 3/11 is going to repeat. And then 2/7 is my last one. Okay, now let's stop here a minute and talk about this idea of non-terminating, non-repeating. Okay, non-terminating, non-repeating means it doesn't stop and there's no pattern, there's no repeating number. Now, so what we're going to practice doing now is some of this long division. They want us to express each rational number as a fraction in its simplest form. So, if I look at the first one, number 1, once again, it's negative 0.8. Well, I can write that as 8/10. Again, if it's one decimal place, it's the tenths place. And then we can reduce that to negative 4/5. If I go to number 2, well, we've got a decimal again. If it's 2 decimal places, then that means we're over 100. And once again, we can reduce that fraction. And I think 5 goes into both of those. And so we end up with 43 over 20. Now, here's where the fun begins. We have this idea of repeating decimals. Now, if every decimal is a repeater, I can just look at that and say this is going to be 7/9. Okay? And I'll show you, again, we learned the long drawn out way last year. With the Mrs. Burton calls it the n thing, and we're going to look at it in a second. But if every decimal that I have is a repeater, I can just say it's n over 9. It's the tenths place, and then it's 10 minus 1, which is 9. When I look at number 4, once again, I've got repeating decimals, but all of them are repeaters, so it would be 123 over 999. Once again, it's 3 decimal places is 1,000 minus 1, 999. Now, I can reduce that fraction. Okay, we can reduce that fraction by 3s, and so we would have 41 over 333. Now, when I get to number 5, if you notice, I have a repeating decimal, but not all of them are repeaters. Okay, not all of them are repeaters. And so this is where we have to do what Mrs. Burton calls the N thing. Now I'm going to go to the next slide because I got more room to work. And so the N thing, we're going to see that N equals 0.3. N is any number, and our number is 0.39 repeater. Now, if you notice, only one decimal place is repeating. The bar is only above the 9. So that means we're going to multiply both sides by 10 because only one decimal place is repeating. So we're going to go ahead and we are going to multiply that second side, and that really just moves my decimal place over 1. So we've got 3.9 repeater. Now, to get rid of the repeater, to get rid of my repeater, here's what we have to do. We've got to subtract 1 from this side, just like we did on the others, 9. And over here, though, we're going to subtract the original. Okay? Now, the original is what we multiplied 10 by, which was 0.39 repeater. Now, here's the deal. What am I going to plug in right here? Well, I'm going to have to plug in a 9 because my 9 is what was repeating. That's an important thing to see. And then these 9s are going to cancel. And I have, then I'm going to subtract. So we've got 3.6. Now we're going to divide both sides by 9 to get N alone. Now, I've got a decimal in my fraction, so we're going to make this 36 over 90. Remember, I can't have a decimal in my fraction, so to get rid of it, I need to multiply the numerator by 10 to get rid of my decimal place. And what I do to the numerator, I also do to the denominator, and then I can reduce that fraction. If I go to reduce that fraction, then what's going to happen? Well, 9 goes into both of those, I think. And we're going to get 4 over 10, and then I can reduce that again and get 2/5. Okay? All right, kind of long and drawn out, but it's what we have to do when I have a repeating decimal, but not everyone is a repeater. Now, let's look at number 6. First of all, I got a negative number, and then the second thing is I've got 2 decimal places out of the 3 decimal places that are repeating. So we're going to say N. Let me change colors. We'll say, let's get rid of that so we have room. Okay, so we're going to say N equals that number, 1.542, and our bar is over 42. So how many places are repeating? 2 places are repeating. Well, 2 places repeating is hundredths place, so we're going to multiply both sides by 100. Now, when I multiply the second half by 100, that's just going to move my decimal point over 2 places. So I've got 100n equals negative 154.2. Everybody understand what I did? All right, now, remember, how do we get rid of the repeater? Again, I subtract 1 from 100 to get my 99, but what do I subtract on the other side? Well, we're going to subtract the original, 1.542. Now, unfortunately, both of these are negatives. That's if they're the same sign, we're going to add and put that sign. And we're going to have to repeat our 42 here because I need the same number of decimal places. All right, so let's add everybody up. We've got a 4 and an 8 and a 7. And then we've got 155. There it is. Okay, so now I need to divide both sides by 99. So we've got 155 and then 784 over 99, and then we've got 3 zeros. And now, believe it or not, we're supposed to reduce that fraction, but we're going to stop right there and leave it there. So big picture though, realize, figure out how many spaces are repeating. That's what we're multiplying by. And then remember, to get rid of the repeater, we subtract 1 on the end side and we subtract the original. We subtract the original on the back side. And remember, you're probably going to have to repeat some decimals so you can have the same number of decimal places. Good job.